In this video, I will demonstrate how to use USB device firmware update class to implement firmware upgrade on EKRA6 M5 board. Renesas provide example project for USBX DFU class on their GitHub repository. If you open notes.md file, it lists out all the software and hardware requirement for this project. USB communication have different classes based on how we want to configure our peripheral device. Some of the important classes are human interface device, communication device class, mass storage class, audio and video class, device firmware update class, printer class, or media transfer class. In this project, we will work with CDC and DFU class. The USB DFU class is a standardized mechanism that lets a device update its firmware directly over the USB without needing the external programming hardware. Also, on host side, we can talk to any DFU capable device without needing a vendor specific drivers. In extended version of USB DFU class, we can also update the data in peripheral device. If you further scroll down in notes.md file, you can find step-by-step guide to implement this project on your hardware device. As mentioned here, I have implemented this project before. I can skip the step 5 to 9, but you are required to implement these. Here in notes.md file, total 11 steps are mentioned. When using this project for very first time, you need to implement these 11 steps as they are mentioned here. If you scroll down further, you can find download link for DFU util binaries and ZDIC program. If you open readme file of this example project, here you can find detail related to hardware connections. You need to connect two micro USB cable with EKRA6M5 port, one with the debug port and one with the USB full speed port. As shown here, J12 and J15 jumper should be connected like this. When downloading example project from this GitHub repo, make sure these example projects are based on the same FSP version installed on your system. Otherwise, you can face compilation errors. It is always preferable to download latest eScare Studio version with latest FSP version. For some reason, if you want to use previous FSP version, you can click on this master tab, then click on tags. Here you can download example project for previous FSP versions. Navigate to the location where you have downloaded the example project. Now open EKRA6M5 folder. Here you can find USBX DFU project. Now open this folder and copy ESK Studio folder. You can paste this folder in the project workspace you are using in ESK Studio. After that, you can rename the ESK Studio folder according to your preference. This application have four stages. First, the system is initialized with the support of interface association descriptor. Then the CDC and DFU classes are initialized with separate interfaces. Secondly, the device mount as CDC class and an application on the host will exercise the DFU class and send the download request. On reception of this command, the system will uninitialize the CDC class and then initialize the DFU class. Then the device will disappear from the bus for a short time for reset sequence. Upon restarting, the device will be exclusively in DFU mode and will download the data sent from the host device. Finally, when the new data have been downloaded, the host application will reset the device. Upon re-enumeration, the device will revert to its normal operation with the new firmware. Later in the video, when I am executing this example project, I will show these four stages in detail. Now open ESK Studio, then click on Import Project button. Here select Import Existing Project into Workplace. Now click on Browse button, then open Project Workplace. Now select the folder we just copied here. Then click on Select Folder button. Now select the project name and click on Finish button. After project is imported, click on the project name, then click on this hammer icon to build your project. If the build is successful, then we don't have any error related to project import. Now if you open FSP configuration file, here you can study how USB device firmware update stack is configured. Now expand SRC folder, then open USBX DFU peripheral device entry.c file. In this file you can find G underscore data underscore DFU array. This array will store incoming data when we use DFU utils. Now if you open USB XCDC DFU peripheral device entry.c file, in this file you can find a flag variable to indicate that the downloaded has been completed from the host device. In debug mode, we will add a breakpoint here to check the G underscore DFU data array. Now click on your project name, then click on this hammer icon to build your project. To connect with Sagar RTT terminal, we need the address for Sagar RTT block. For this, you can open debug folder, then open .map file. Here you can search for .bss underscore Sagar RTT. Now from this file, we can copy the address for Sagar RTT block. Now right click on your project name, then select debug as, then select NSS GDB hardware debugging. Now click on switch button to open debug perspective. Now click on window, then click on show view, then click on expression window. Now expand expression tab, then add G underscore DFU underscore data array in expression window. After that we can enable real-time update for this array. Now if you examine G underscore DFU underscore data array, if we expand further, it is divided into 100 equal parts, and when we expand first 100 elements, we can check that they have been initialized with dummy data. Now click on this resume button and then again check the DFU data array. Now the array have been initialized to reset value, which is all zeros. Now open Sagar RTT viewer, then use address option to connect with Sagar RTT terminal. Now open eScale Studio, then open USB XCDC DFU peripheral device entry.c file. Then I am adding a breakpoint at line 229. Then again click on the resume button. Now if I open Sagar RTT terminal and check out the log, I can observe that the first stage of this application is executed successfully. After system initialization, both stacks CDC and DFU are configured successfully. Now if I open ZDIG program, then click on device, then click on list all devices, we can observe that EK RA6M5 device is configured as USB CDC device. Also on RTT terminal, you can observe that CDC device is configured. Now if we use DFU util binaries to transfer data.txt file on Sagar RTT terminal, we can observe that CDC device is changed to DFU device. This is the second stage of this example project. There is a short pause for reset sequence. After reset, device will be exclusively in DFU mode. After that, data transfer will take place. This is the third stage of this example project. Now open eScale Studio, then click on expression window. Now if you expand G underscore DFU underscore data array, you can observe that this array have been filled with data.txt file. When using binary or hex file, this data can be used to update the firmware in device. The program execution is halted at line 229. We can again click on this resume button. Now I will show you the fourth step of this example project. Now if we check RTT terminal, the last line printed is download data integrity pass. After that the device is resetted. After the restart, the device can revert to its normal operation with new firmware update.